But how did the missile lock, and how did the F-35 use evasive maneuvers? Once an infrared-guided missile is launched, the dynamic of the engagement changes to a race of physics and countermeasures. When the missile's IR seeker head locks onto the massive thermal output of the F-35's engine exhaust. But the detection, the F-35 is equipped with a distributed aperture system, 6 infrared cameras positioned around the aircraft that provide a 360-degree spherical view. The distributed aperture system detects the intense heat signature of the incoming missile's rocket motor and instantly alerts the pilot. To break the lock, the pilot executes high-G evasive maneuvers while simultaneously deploying flares. If the missile tracks the flares but is already within a lethal radius, its proximity fuse will trigger the warhead. The resulting shrapnel and shockwave can cause significant damage to the aircraft's control surfaces, stealth coating, or internal systems without scoring a catastrophic direct hit, which perfectly aligns with reports of the F-35 sustaining damage but safely executing an emergency landing. But what are flares? These pyrotechnic countermeasures are made of magnesium or other combustible metals that burn at temperatures exceeding the aircraft's engine heat. The goal of the flares is to overwhelm or confuse the missile's IR seeker, forcing it to chase the decoy heat sources instead of the jet. But what is Iran's secret weapon? We believe it's the 358 anti-aircraft missile, or the SA-67. The 358 is a unique hybrid between a loitering munition or kamikaze drone and a surface-to-air missile. But how does it work? It flies at slower subsonic speeds and can loiter in a designated airspace in a figure-8 pattern until its optical and infrared sensors detect a target. If a 385 missile or a more advanced high-speed indigenous IR-guided surface-to-air missile was guided by a ground-based IRST network, it could engage the F-35 entirely within the infrared spectrum, bypassing the jet's radar-evading capabilities entirely. This incident challenges the long-held doctrine that fifth-generation fighters can operate with total impunity in contested airspace, highlighting the evolving threat of infrared detection. But it has its advantages, as it cannot hit fighter jets far from its radius of launch system.